I'm going to understand. All right. So I suggest you should be having a pen with you. And network is not the subject that is. It's not like a storytelling or any theoretical subject. It is the applied subject that you should be having your pen and pencil and the note. And whatever I'm telling, whatever I'm explaining, it is better if you keep on drawing, writing, or drawing the circuits, writing the equations. It is always preferable. Okay. So today let us start with the basics. Basics of circuit. Today, since it's a first lecture, so let us cover basics. Now let me just see how many people are there. Okay. There are 32 people. Okay, 32 students who have joined. That's good. I'm going to take that again afterwards at the end. Okay. So, some things you are knowing, you are already knowing, and some things might be new. Whichever you don't understand, you need to. Okay. So, let us see first what is the meaning of a network. What do you mean a network? Okay. So, it is simply electrical network. We are dealing with the electrical network because network is there are lots of networks. Uh, we are talking about electrical network, which is having electrical elements. Okay, so a circuit, an arrangement of the various electrical energy sources along with different circuit elements is called electrical network. Okay, arrangement of the various electrical circuits. Right? So this one, let me highlight. Let me see. Any arrangement of the various electrical energy sources along with the different circuit elements is called electrical. So, highlighted part is important to you. Okay, now let's go ahead and let's see the basic concept. What is the meaning of branch, junction point, node, mesh? Okay, this is the simple electrical network. This is one electrical network. Okay, then what you can call the network having the sources. These are the sources. E1 is the source and E2 is the source. It's a battery source, it's a DC voltage source. Okay. And the circuit element, since it's a DC, there will be only resistance. If it is AC, there will be resistance, inductance, capacitance. Okay. Now, these are the resistances. There is R1, there is R3, R2, R5, R6. These are the resistances. Fine. Then, this is called as a branch. Branch is AB. This is called as a branch. Okay. Then, these are the nodes or the junctions. This is junction B, junction C. These are the junctions. Okay. Then there is a mesh or the loop. Loop is if I start from A, B, then C, D, and back to. So this is forming one loop. Okay. And the D, C, F, E, and back to D, this is forming another mesh. Okay. So there are two loops. Okay. These are the two loops they have defined. Okay. A, B, C, F, E, G, A. Okay. And this one is another one is this is D, F, E. These are the loops. These are the loops. Okay. Fine. So this is very simple to understand. What is the meaning of electrical network? Which I'm just revising it again. Electrical network will have energy source and it will have electrical elements. We are dealing with a simple DC circuit, so there will be a source DC source, and a simple electrical element which is resistance. Okay, we have understood the concept of node, junction, loop, branch. That's Now we will go ahead with the classification of electrical networks. Classification of electrical networks. Okay. The first one is linear network. This is linear network. And the definition is a circuit or network whose parameters, that is elements like resistance, inductance, capacitance are always constant irrespective of the change in time, voltage, temperature, etc., is known as linear network. It's simple. Okay. The circuit whose parameters means resistance, capacitance. There are no other parameters. Three parameters. In case of DC, there is only resistance. In case of AC, there will be all these three parameters possibly. These parameters, they will remain constant irrespective of the change in time, voltage, temperature, especially. Then it's a simple linear network. Okay. So, and what is a non-linear network? This is a non-linear network. Yeah, I have to admit. I have to admit this. Okay. Go back here. Non-linear network. The circuit whose parameters change their values. A circuit whose parameters change their values with change in time, temperature, voltage, they are called the nonlinear network. Nonlinear network where the circuit parameters they are changing with respect to the time, temperature, voltage. Okay, one type of a classification. The second is a bilateral network. Bilateral. A circuit whose characteristic behavior is seen irrespective of the direction of the current. So various elements of it is called as a bilateral network. Okay? Circuit consists only resistance is a good example of bilateral. Okay? So the characteristics behavior is same irrespective of the direction of the current. Okay? Unilateral network, the circuit whose operation behavior is dependent on the of the current through various elements is called as a unilateral network. Okay, so circuit consisting of diodes. Okay, so diodes the flow of current in only one direction. It is a good example of unilateral circuit. So you should be knowing the types of the circuit, the classification of the circuit. At the same time, you should be knowing the example of the circuit. Okay. So we have seen the linear, non-linear, unilateral, bilateral. Okay. On Monday, I'm going to take the revision of this. Okay. So you should be explaining me the classification because this part I'm covering it today. Whatever I'm covering it today, I want answers on Monday based on this syllabus. Okay, I don't think this is very difficult. It is really simple. This is just like your theory, and it is very much required. Okay, so that you will come in line. Okay, and there will be a proper flow. Okay, whenever you want to have a good marks in the exam, your start for the preparation for that subject is very important. If the starting is good, definitely you are going to achieve good marks in the exam. Because once you start your what you say, good start, okay, is always beneficial, okay, and that will definitely interest. It will create interest in the subject, and that is what very much requires network analysis. You should feel that the subject is interesting, then and then only you will solve more and more problems. Okay? Because network is totally solution, numerical of problems. The numerical or the solution of the networks. Fine. So we have completed linear, non-linear, now unilateral, bilateral, skills, active network, and the passive network. Okay, this is the next type of network. So the active network is it will contain at least one source of energy. At least one source of energy. So this is the example of active network. You are having this voltage source, you are also having this current source. And the passive network will not have any energy source. So isn't it simple to understand? So active network is the network which is having the source, energy source, at least one, and the passive network will not have any energy source. Okay? So the circuit which contains no energy source is called as a passive circuit. Fine. So this is the next classification of network. And now the next one, and this is probably the last one. The lumped network and the distributed. Okay, the network in which all the network elements are physically separated. The network elements are physically separated is known as the network. Okay? Most of the electrical networks are lumped in which consist elements are RLC voltage sources. Distributed network, a network in which the circuit element like resistance, inductance, etc. cannot be physically separable for analysis purposes. It is called as a distributed. The best example of such network is a transmission line, where resistance, inductance, and capacitance of the transmission line are distributed all along its line, cannot be shown as a separate elements anywhere in the circuit. Okay? So these are the definitions of lumped and distributed. So, so this is the summary. This is a summary of the first point that we have covered. Okay, electrical circuit classification of networks. So the first point of the we have completed. Okay, which is the classification of network. So active and the passive. Can anyone tell me what is active network and passive network? Can anyone tell me what is active network and passive? Yes. Can anyone tell me what is the meaning of active network and passive network?
Ma'am, active networks have a voltage source, whereas passive networks do not have a voltage source or energy source.
Very good, very good. So in online lectures, if you are attending, and I feel very happy because I'm not able to see you, but of course I will see you on Sunday. That is a very good thing. The point is, whenever we are completing, and these things, the basic things are really simple to understand. Just keep these things in mind. You understand it, then later on we need to actually apply it. So talking these terms directly in the class, then if you are having this revision, it is always better for you to understand the next concepts. Okay. Next is again linear and non-linear where behavior, okay, or the is the elements, these elements, they are their characteristics, they are independent. Okay, they are not dependent on changes in the time, voltage, temperature, etc. Unilateral, bilateral, the characteristics they are depending upon the direction of the current. Lumped and distributed, where the parameters are separable or they cannot be separated, physically separated. Okay, so the point is we should be classification of network, and you should be able to explain it with example. That is what required. So our first 5 marks or 6 marks question is like this, okay, which may come in your semester examination. Okay, let's go ahead. Let's move ahead. This is not a is not very difficult that we have covered. Now let's go ahead. We will deal with now the energy sources. Okay, energy sources. There are two types. One is the ideal source, and the other one is the practical source. Okay, now voltage. We will see ideal practical source. Also, the first one we will see as a voltage source. Okay, there are only two sources, voltage source and current source. Let us see the voltage source. It is drawn like this. It is drawn like this. Okay? So it's a voltage. If it is a DC, then you have to draw the polarities. For a DC source, you have to draw. This is a symbol. Okay, this is a circuit or the network when it gets completed. So you connect the load. You connect the load across the source. Otherwise, it's open circuit. These are the terminals which are shown as a open circuit. Okay, open circuit. And if you connect a load, then it becomes the open circuit. These are the characteristics. These are the characteristics. The characteristics are between the voltage and current. So as the current increases here, the voltage will remain constant. Voltage will remain constant. Node voltage is equal to source voltage. That is the main. Okay, this is the ideal voltage source. Fine. So we have characteristics. We have got. Let us see the practical voltage source. The practical voltage where this is the ideal source and there is the internal resistance. If you are using a battery ideally battery will give you 12-volt battery. Will should give 12-volt continuously. But practically there is later on there is a drop in the voltage. There is a drop. So it drops here. Okay? Because there is internal resistance associated with the battery. We call this as a series resistance. The series resistance is there connected to the battery, and this is the node. This is the node. The effect is the source voltage will not remain constant. So these are the ideal characteristics, and these are the practical characteristics. Okay, so this is a practical voltage source. When there is no load, I is equal to 0 and V is equal to 0. Whatever is given in the blocks, okay, these are the practical voltage characteristics. Practical voltage source. So there are only two sources, voltage source, current source. And again, there are two types, practical source and the ideal source. Okay, so we have seen the voltage source. Now let us go to the, so this is simply the drop across the series resistance. That's why you can see the drop in the load voltage later on in case of a practical voltage source. In case of ideal voltage source, there is no internal resistance. Okay. Then again, here this is the time invariant source and time variant source. Okay, so ultimately it's an AC source. It's an AC source that is as an AC source. So this is what is shown over there. Okay, let's move ahead to the current source. Let's go to see the current source. Okay, the current source, this is the symbol of the current source. So we have, for the voltage, we are having the polarities. For the current, we are having the direction. We are having the direction. And we write here as IS. And for the voltage, we write as a voltage. I suggest you draw these things. They are very simple to draw, simple to understand. And these are the basics on which our further circuitry is. Okay, so you should be knowing what is the voltage source, what is the current source, how to draw the voltage source, how to draw the current source, what are the characteristics of ideal voltage source, practical voltage source. Now this is the ideal current source. We're talking about the ideal current source will be delivering the current. Will be delivering the current. So this is the current versus voltage characteristic. Current versus voltage. And the current, load current will remain the source. Load current is the current which is going into the load. Now this load can be can be resistance, it can be since it's a DC one, so there is only a resistance. Okay, just you imagine it's a filament, it's a normal tube light. Okay, there is a water heater, resistive load that is in. So the current is flowing into the load, so it's a load. Okay, this is ideal current source. Now let's see the practical source. Practically, there will be resistance, but there will be resistance, and this resistance will now be in parallel. In the case of a voltage source, where the series resistance was obviously the name is called as the series resistance, internal resistance that will be increased. In case of current source, the resistance in parallel. That is the difference you have to remember. Okay? And node will be obviously there and the current here so this is the ideal current source RSS will be defined because if it is zero then it will be it is in the time variant time period and we have given with the AC source. The AC alternating current with the sinusoidal current which is the function of the current. So right now we are proceeding with the DC source. Next point. So we have covered two points. The first one is about covered voltage source, current source, voltage ideal and practical source, current ideal and practical source. Now let's go to this particular. So the dependent sources. This is something like some part. This is important and this you have to face. These are the challenges you have to face with this challenges, your problems. Dependent sources. Now, these are the types. These are the only types. Four types of dependent sources. What are these? Voltage dependent voltage source, current dependent current source. Okay? Because there are only two sources, voltage source, current source. And they are depending on either current or voltage. So there is a possibility of four sources. So voltage dependent voltage source. Now this is the first one. So if you see the diamond is always a dependent source. Diamond is always a dependent source. If it is a polarity, if you are showing the polarity positive and negative, that means it's a voltage source. And if it is depending upon the voltage, it is depending upon the internal voltage, somewhere, because when I take the example, then you will understand that from where this V1 is coming at, etc. It is depending upon voltage, which is internal. So V is equal to 3 times V1. So this is the voltage source and it is depending upon this voltage. And therefore, this is the first one, voltage dependent voltage source. Okay? Then there is a current dependent current source. Again, it's a diamond shape. But this is a current source, so it will have an arrow. It will have an arrow. And it's depending upon some constant multiplied by the current. Some constant by the current. So it is a current dependent current source. Okay? So simple to understand. Nothing big in this. Okay? Next is current dependent source. Now you should tell me voltage source. So if you have to show the polarity. You have voltage source, and it is dependent upon the current. So this is K into I. It is a voltage source. It is a different source, no doubt about it. That's why it is shown in the form of a polarity, but it is dependent upon the current. So it is K into I. Then the last one is voltage dependent. So ultimately it's a current source, so there will be the actual, but it is dependent upon the voltage. It is I is equal to so it is a voltage dependent current. So these are the four possibilities you should be remembering. You should be remembering. I'm not going to take these things again in the class, for sure. I'm going to go again. Okay? I completed current source, voltage source, ideal, practical, I have completed, and the types of okay. So anyone having any doubt so far, anyone having any question so far, you can ask me. Okay. I'm share this material with you, but this is not very difficult to understand, but you need this information to solve the problems later. Okay. If you don't have any doubt, I'm going ahead. All right, let's go ahead. Uh, you need not worry this. You need not worry this. There are a lot of problems mentioned. Now let's start with our first important law, Ohm's law. Ohm's law. Are you able to see this?
Yes, ma'am.
Okay, thank you. Ohm's law. This is the basic law, and electrical engineer should not forget this. Okay. So what is Ohm's law? It is, of course, it is given by Dr. Ohm. Obviously, this is the law. I will read it for you. The current flowing through the electric circuit is directly proportional to the potential difference across the circuit and inversely proportional to the resistance of the circuit, provided the temperature remains constant. This is the clause. This is important clause. Provided the temperature remains constant. Okay? Mathematically, this is I is equal to V upon R. I is equal to V upon R. So if there is a resistance, there is a potential difference applied across it. So this is a positive terminal, this is a negative terminal. When you apply potential difference across it, the current I is going to flow through this. Current I is going to flow through this, and you are going to see this relation I upon I. Okay? And this is the Ohm's law. I is equal to V upon I. You should not forget this law in your case. Many times, all the time you are going to see this. V is equal to I into R, or I is equal to V divided by R. Now, in this equation, R is constant. R is constant. Okay? So, the Ohm's law, basic. Okay? This is Ohm's law. You should know this. Okay? Then there are limitations of Ohm's law. Okay? Let's let you may read this later on. Okay. Okay. Uh, Inductance. versus VI relationship. I think this is also fine. There is an inductance. This is AC we are talking. This is voltage applied. This is the relationship. V is equal to L di by dt. You should be remembering this. V is equal to L di. I am revising this. Those who have completed first year, they have done basic electrical engineering, then but still you need to revise. Those are having direct admissions. But I think these concepts you might have done in physics or in electrical from right from I think 8th standard, 9th standard, maybe 11th, 12th. So these are not new. These things are not new to you, but you should know this because our further circuitry is definitely depending upon your understanding, basic understanding. Okay, so this is LDR/dt. Okay, power energy stored in the factor is hot juice. Okay, this is capacitance. Capacitance. Capacitor voltage is associated with charge. Okay, this is the relation. I is equal to T V dt. I is equal to C dV power is 1/2 series. Okay, this is R V is equal to I into R. This is L di by dt. 1 upon C integration I dt. This is for the current. Very simple relationships of resistance, inductance, capacitance, but these things are really important. Okay? Then there are certain things. So this is some examples. Simple examples I've taken. I'm not going to go in details. Resistance in series. Resistance. What is the effective resistance if resistances are in series? What is the effective resistance? What is the effective resistance? If R1, R2, R3 are in series, yes, resistances in series. I want answer. This might be the last part. We will stop afterwards. Anybody knows? 34 students are there. What is the total resistance if I connect R1, R2, R3 in series? Wrong answers, okay. No problem. No problem. I want you to see the effort you are making. What is the effective total resistance?
R1 plus R2 plus R3. I mean REQ equivalent.
Very good, very good, very good. I like if the students are attentive. This is really simple. The formula is also simple. So R is equal to R1 plus R2 plus R3. If they are in parallel, inductor we won't do it now. Inductor anyway we don't have to go for this type of a circuit. We have to go for the circuit which is much more complex. And resistances in parallel will have this particular equation. 1 upon R equal to 1 upon R1 plus 1 upon R2 plus 1 upon plus up to 1 upon R3. Okay. So this is the you have to face these things a lot many times. So resistances in series, resistances in parallel. Okay. Capacitance, inductances in series and parallel will not be there for your solution. Okay, so I am not going to take it you may do it afterwards. Okay, resistors and resistances in series and in parallel combination, you should be you should be able to solve this type of problem, like the total combination, series and parallel resistances. Okay, so I suggest you solve some problems that you find the effective resistance, find the effective resistance of this. Okay, okay. Can you do it quickly? Can anyone do this quickly? Find the equivalent resistance between the points A and B. Who can tell me this answer? Then we will stop. Students, you should be attentive if you want to pass in network analysis. Otherwise, you have to be very active. You have to solve. You have to tell me the answers. Be interactive. As I said, this is not a story telling session, and this is a simple problem I have given. So first, this 4 and 3, they will be in parallel. That is with this. So you have to add this. 5 plus 6 you have to add. Okay. And these three will be in parallel. These three will be in parallel. Okay. And later on that will be adding to 1. That will be adding to 1. Anyone able to tell me the answer? Quickly. This is 9 o'clock. I will stop, but I want answer. Someone, someone who is clever, or rather someone is attentive. Because here, what matters is the calculation. So 3 and 4, they are in parallel. So this is 1.2. 3, 4, 4, they are in parallel. Okay. Then that will go in series. So this is 3.2. This is 11 and 7. They have done in parallel. And the total resistance is this. So if you were calculating, it was 304. Network is the calculations. Like short and open circuit. This requires understanding. What is the meaning of short circuit and what is the meaning of open circuit? This requires explanation, and I can provide it on Monday. So I think enough for today. Enough for today. Voltage division, etc. So those things, of course, that is required. This is required. What you can say, the attention. So I think we will stop. I think we will stop. I hope you are understanding, and I hope you are. This is a simple revision that I have taken, but all these things are really important. Okay, who is CR by the way of your class? Who is CR? Is he here? Okay, just a minute. I will take the attendance at the end. Please be on time.